Okay, so our project is the vertical air wind turbine. The group members are D'Angelo, Robert, and me, Eunice. So our problem definition, we needed to provide an affordable, eco-friendly wind turbine for residential use. We needed to design and manufacture a guard to increase the efficiency of the turbine. The design constraints, the blade material must be light for an effective turbine. The material must be cost effective due to the limited budget. The design must be able to fit in the wind turbine and the wind tunnel for testing. The design must be able to withstand weather conditions. The guard must be adjustable, and all the manufacturing processes should be done in the CCSU basement lab. So our target users are the residential customers, such as households that wants to reduce dependence on using non-renewable energy resources, and also households without stable access to electricity that can benefit from an affordable renewable energy source. Previous iterations. So the data showed in the vertical air wind turbine works best with 6 or 9 airfoil. And our main objective is to create a stable guard to increase the efficiency. The guard should be able to move to allow the testing. We're going to try to repair frame to avoid wobble when the turbine is in use.
All right, so based on our analysis of the previous group's presentation and their work that they shared with us, their recommendation was that a deflector, which we are calling a guard, would benefit the design by preventing the wind from creating a negative torque. So basically funneling all the wind to one side of the turbine so that you get maximum energy creation. And our team members, we all have our strengths and weaknesses. I think we round out each other pretty nicely. I don't think we have too many people with overlap in our struggles. Our proficiencies kind of mesh nicely with each other, so hopefully we'll be able to have limited problems with this project. The tasks that we're working on, so we need to have a design for the frame, the rotating shield or guard, and the airfoils. We might want to improve on the airfoils that already exist. We know we need to modify the frame slightly to prevent from rocking or wobbling, and the rotating guard is the main thing we're going to be focused on. As far as the manufacturing aspect, want to avoid machining the airfoils because I just don't think we have the tooling for that in the Copernicus basement. We need to find some material for the shield that we can use to manufacture, but it's also going to be light because we don't want to make the design too heavy. And working on repairing the frame, we're going to need to kind of visually inspect that and see exactly what we want to fix or redesign or replace. But that might also be a manufacturing issue. And the tasks we have completed so far, we read the previous group's final report to see what we needed to change or improve, and we created the CAD drawing of the vertical air wind turbine and put the rotating guard on it, so we kind of know what we're looking at. And D'Angelo will tell you a little bit about that design.
Okay, and here we have the basic CAD drawing, the concept of the guard that's going on. As I stated before, we wanted to input a sort of a shower curtain type of design where, in this case, we would slide the guard based on the direction of the wind and where the user would actually like to put the guard. I mean, the part is actually not to. We'll work on that. Here we have the Gantt, what we still need to resolve. But, based on the current circumstances, it's going to be a little difficult. The tasks assigned are, well, based on the current circumstances, we cannot follow the Gantt chart. And instead, we decided to prepare to learn CFD to prepare for the future tests in case we have to redraw and actually apply CFD onto our model. In conclusion, as stated before, due to the current circumstances, we are not able to access the CCSU labs for the rest of the semester. Therefore, we are going to be behind, but we should be able to get back in shape if we would access to the actual model and then work for it from there. Most of our tasks will be postponed until the summer or until further notice.
Hopefully, the school will be back open this summer. We can get back to work on it. Right now, D'Angelo did that 3D model in SolidWorks because we don't have access to NX10. We haven't been able to make any measurements of the existing models. We're not sure about the scaling. It's kind of just a rough draft, but he did a pretty good job with that. And that's the best we can do for now with what we have.
Thank you very much.